Greetings and welcome to the short video on rank order distributions. Let me get the title up here on the board. Rank order distributions. Okay, so essentially, distribution is some kind of way of organizing our data. In this particular case, we're going to be doing a rank order distribution. And this is just simply an ordered listing of data in a single column. Okay, so what is an example of this? Let's just say we have a random variable x, and x equals the number of pull-ups that you're going to measure in a PE skills test. And we're going to measure 10 students' scores on their ability to do pull-ups. And so you do this and you come up with some raw data. Let's show what this raw data might look like. So let's just say we have some raw data in the exact order of how you measured the students, and let's just say it came out like this. Somebody did 12 pull-ups, then somebody did 10 pull-ups, 9, 8, 2, 5, 17, 14, 15, 18. So that's the raw, right in order from the very first individual that you measured, then the second student that you measured, all the way up through the 10th student that you measured. Okay, and so in general, there's not necessarily anything wrong with getting this raw data. The problem is, for us, it's really difficult to interpret because this is not organized in any kind of methodical way. So not organized. And so what does a rank order distribution do for us? Well, essentially what we're going to do is we're going to place the scores in a list from high to low, and you could switch this. You could switch it and make it low to high, high to low. Doesn't necessarily matter. What is that going to do for us? It's going to be easier to interpret. It's going to be easier to see the spread of the group, and you'll even be able to look at things like the range, or even kind of intuitively look and see what the middle score might be. So let's just kind of place this now in this kind of form. So we're going to take this distribution here, here, and we're going to place it in a rank order distribution. So remember, x is our random variable, which is the number of pull-ups, and we're going to place it in rank order. So the highest score here was this 18, and I'll just kind of do this, was this 18, right? And so it's going to go down here as our highest score. Then the very next score would have been this 17 right here, and so on and so forth. So if I just continue to put these in descending order from highest to lowest, it'd be 18, 17, 15, 14. I could even cross these off if I wanted to. If I wanted to go up here and cross that one off and then cross this one off, this one, so on and so forth, but not necessary though. 12, 10, 9, 8, 5, and 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10 of our numbers are now in this master rank ordered list, going from high, the highest score, to the lowest score. And this is a rank order and distribution. And it does a number of things for us. So, what is the total number of scores here? Well, we represent that by the number, or the letter n, and n equals 10, signifying we have 10 individual cases of scores here that have been measured on this random variable x, which is the number of pull-ups. And then we can look at this and easily ascertain from this rank order distribution, and not having to kind of sit here and make these odd comparisons in this list. But when you're starting with the highest, the rank order distribution allows us to immediately go right here and say, what is the highest value? Well, the highest pull-up value was 18. Well, what is the lowest? The lowest one right here at the bottom of the list was 2. Well, this also allows us to do something like calculate the range. Well, what is the range? The range is defined as the high score minus the low score. So if we just do the simple arithmetic here, 18, which was our high score, minus our low score, which was 2, so the range here would be 16. So you can kind of see there's a rather large spread in this particular group and the ability to do and perform this pull-up skill. So this kind of rank order distribution works really well when the number of individual cases being studied is rather small. However, you can quickly see that if this got up into 20 data points, 30 data points, 40, 50 data points, this would be a very onerous task. And so we're going to need another type of distribution for these larger data sets. But that will be for a different video. Thanks for watching the video on rank order distributions.